Hello everyone. I'm Abu, and I thought it'd be cool to share some of the forensics challenges from Worldwide CTF. It was really well made. So let's pull up the challenges page and go into forensics one. Yeah, we managed to solve a couple of challenges, but we weren't really fully focused in the CTF, so a lot of missing ones are there. So this is the challenge in question. So it's called forgot password, and the objective of this question is the person in question had forgotten the answers to the security questions in Windows, which is used to reset or do some uh, other stuff when you have actually forgotten your main password. So we've been given a Google Drive link, which I've already downloaded. It's an AD1 file. So AD1 as a file format is a proprietary software for FTK Major. So whenever you encounter AD1 file, it's pretty normal to pull up FTK Imager and do your forensics analysis on that. So let me just open up FTK Imager. Yeah, yeah. So once you open up FTK Imager, you go into files and add evidence item. And in this case, you'll be adding an image file because an AD1 is an image file. If you want to add a physical drive, for example, when you go to physical drive and click on next, it will give you all the physical drives that are physically connected to your computer. So which is irrelevant to our current scenario. So we go into image file, click on next, and enter the source path. So you click on the file in question, so evidence.ad1, and click on finish. And then once we've actually loaded um, the file in FTK Imager, it'll automatically um, sort of act like a directory tree, uh, which we can go through and find a lot of interesting things in the file system. So it acts like a file explorer of sorts because so once you open up all the directories, we'll actually be exploring all the things that are in our directory. So the since the objective of this question is to find the answers to the security questions, um, as I've already gone through this question, um, the thing that should strike in that should come into your mind is something that actually um, is common. So when you think about finding the answers to these security questions, you should usually be looking at registry files and hive files in System32, which is the primary storage for all the critical files. So under System32 on config, this is another important directory that we will be focusing on. The the ideology behind visiting System32 is because let me pull up uh, this browser and type in where are system security questions stored. So we see that once you do some research, you'll actually find out that it's actually stored in the users Windows and System32, and under System32 we have the config, and you see a lot of registry files. You have the SAM file, and which is pretty common when you do password extraction using Mimikatz or something. So that is a really useful thing to have. So once you have this directory, you'll need to extract it or export it into your local directory because it's not um, a physical being in your file system. So you need to export the files, the whole directory into your file system. So once you've done that, Okay, my antivirus is already screaming. Uh, Now, this is not recommended, but since this is a learning environment and we're actually doing this for a CTF, uh, it's not recommended, but I will be turning off my real-time protection. And yeah, so that way we can proceed with the analysis. So once we've exported the files into our local system, so here is a directory. We see all the files in the system. There is a software known as there is a software that's called, I'll pull that up. It's called software. It's a really security questions. So it's a really cool tool that basically takes in the config directory and displays all the security questions and the answers to the security questions. That is the objective, and this tool really does a good job in doing that. So we open that up, and then you'll be asked to either load questions, security questions from your local system, which we do not want to. We load security questions from an external drive, which we are about to do. And another uh, kind of uh, kind of disadvantage to this is that we need to be typing the entire directory of the file system. So we'll just copy this and paste this in there. Okay, okay, not this. Let's pull up the config directory file location and paste it in there, and then click on OK, and there you have it. So here we've extracted all the security questions, and in the answers we find the flag to the first challenge. So that is challenge number one, pretty cool. And challenge number two is a much more difficult and elaborate challenge. Again, author Odin, props to him, really wonderful challenge. So in this challenge, our system was attacked by a mysterious attacker. Could you help me recover the system and trace their footprint? And the flag has two parts, and we've been referenced the same Google Drive link with the same evidence.ad1 file, which we've already downloaded. Um, so the objective of this is to trace back the mysterious attacker and find out what he did in the system, and let's do some more analysis. So let me close this up and open up FTK again, and we see that there is a user called Wukong. And under Wukong, if you go into pictures, you'll be finding a lot of file extensions that end with .odin. So this .odin file should immediately right off the bat show you that this is kind of a ransomware or some sort of encrypted file that has been affected by the attacker. So it's a good place to start off with. So the first thing that comes to mind is looking at the uh, looking at looking at the history. So when we say history, it's a good opportunity to go and research about where the Brave history will be stored in Microsoft the browser Microsoft Edge, and where the location of the history will be stored. So when we go on to um, our browser and search up where is the history of Edge browser stored in Windows. Okay, so okay, so the Microsoft Edge history location is mainly stored within SQLite database. So it's an SQLite database, yeah, and it's stored under C users username, which is wukong app data local packages, or I guess let's look at another one. Yeah, let's try this. The user profile, app data local, Microsoft Edge user data, and profile. So this provides a trove of history and information related to browsing activities, which can be of great value to investigators. So let's do that. let's go to FTK Imager again, and under C users, we go to wukong, and then going on to app data, we go to local, and after that we go to Microsoft, looking at edge, user data, and default. So if we scroll down, we see we should be looking for history files, and there it is. So just to confirm whether if this is an SQLite database, you just need to double click the file, and turns out it is actually SQLite, since you see the starting hexadecimal representation in SQLite format. So so once we've done that, we can just go ahead and export this. I've already exported this. Let, let me pull up my terminal. So let me open VS Code. Okay, so if when that's loading up, let's do some basic analysis on the history file. If we do file on history, it should surely give us an SQLite database, and there it is. We see that it's an SQLite database, and a lot of interesting files and i- uh, like information should be found in the history database. So we see there's a lot of we see a lot of interesting links. But instead of viewing this from strings, which is a very basic tool, we can have VS Code. We can go on to VS Code, and in extensions we can install something called as SQLite viewer or something. So that extension basically, so this one SQLite, so it basically allows us to explore and query SQLite database. So once you've done that, you open up your command prompt in, or whatever you call it, in VS Code, open database, and click on, wait, let us load. It's loading. Okay, open database, choose a database. I really should think about upgrading my laptop because it's becoming really slow. So click on the history.db file and let it load. And once it's done loading, under the left panel of VS Code, we'll be finding an SQLite Explorer. So this basically parses the SQLite Explorer and displays it in a way that people can easily understand. So the thing we are interested here is URLs probably, and let's show the table. Let's close this out. And the first link that we see is a pretty suspicious one. So Mediafire is basically a file sharing tool, and this was done probably to send or receive malware from the file sharing website. So this suspicious looking zip file is a thing to do analysis on. So if we see other things, these are um, these are probably something that we don't need to concern ourselves with. We can also look at visit source, and there's nothing there. Visited links, okay, edge URLs, and a lot of things that you can do during your initial analysis. I've I've fastened this analysis because I've already gone through this and would explain my thinking process in the procedure. So one thing to note is that this we need to figure out the path of this file. To find out where this is in the system, we usually need to do further reconnaissance and find that out. But before anything, let's just try visiting this in our browser. But this is actually not that safe. But as already I've told you, this is a CTF and it does not involve real and dangerous malware. It is actually dangerous to some extent because your AV screams and all that, but some some trust on the authors, like we have, like we trust them to some extent. Okay, so we see that it's been blocked because it's been marked as a dangerous file. So we can say that during the CTF, this actually served as an obstacle because Mediafire took it down, or else people could have already downloaded the suspicious looking zip file directly from Mediafire, so that would have made things super easier. So this path is blocked. So let's move on to FTK Imager again. And another thing that we could actually do is that we could look at the system's command history. So since this is Windows, we could look at PowerShell and the history from PowerShell. So even I actually don't remember where the PowerShell's history is stored. So let's look it up. Stored in Windows. Yep. So that should give us the location that we need to go. So under user profile, app data, roaming, Microsoft, Windows. Okay. Wait, this is not it. Okay. I don't think this is the one. Yeah, this is the one we need to go to. Yeah. The console history, the console host.history text file. This is the one that actually holds a command line history of PowerShell. So let's go over there. Let's go over to FTK Imager and go under, so under app data, no, app data, yeah, app data, Microsoft. Okay, Microsoft is not there. Okay, strange. So this PowerShell dot console history file is actually stored under the user file, and under app data we go to roaming. So just double click on roaming. Under roaming we see Microsoft, and then we go on to, under Microsoft we go on to Windows, I guess. Is it Windows? We go to Windows, and Windows, wait, Microsoft. I don't see. Okay, Windows. And under Windows, we see PowerShell. And also, if you've been careful enough and noticing, we'll just go one step back and go on to Windows. We see blackmyth wukong.exe file, which should probably be the malware that is infecting our system. So this is something that we need to do further analysis on, but that is for, we'll come back to it in a bit. So once we go on to PowerShell and ps readline, we'll see the console history.txt. This is the file that uh, we've been focused on getting. So you just left click and right click and export file. I've already done it. So let's just pull up my VS Code and open up my history file. So the history file is somewhere over here probably. Okay, here it is. So in this you'll be finding a lot of base 64 strings in here, a lot of them. So the so as any normal CTFer, like you just open this up, pull up terminal, pull up terminal, and try to decode it. Okay, there's okay. I didn't have it installed. You just pip install code and wait for it to install. And okay, Oops, I typed it wrong. Okay, pretty weird. Okay, well, anyway, you just need to paste this string in CyberChef and look at what it does. So CyberChef is really interesting and powerful decryption tool. So let me just open up CyberChef. Wait for it to load and paste it in there. Another important and a cool feature of CyberChef is that it recommends the type of decryption that the the encrypted thing should do. So in here we see that it recommends base 64 and we see it is indeed base 64, and then it gives you a sort of file path of the the exe file. But since I've already uh, gone through this, I've already found out the exact path that we should be focusing on. In the last line of the console history.txt, we see a quite bigger thing of base 64. We copy it, remove the last hyphen, and we see here it's a different location now. So under C directory uses wukong, app data, local, and Microsoft. Okay, there's a lot more Windows, Black Myth, Wukong. So this should be the exact same thing that we've done previously. If we go back to Windows, we see that this is the same file path that is being referenced in here. So once you extract this file, the exe file, I've already extracted it. So let me just pull it up. So here is the exe file. Let me go to file and check out what type of file that is. Okay, so it's a Windows executable. So in Windows, we have something called as PE32 executable file systems or file types, and for Linux, we'll be having something called ELF files, file types for in the Linux and operating system. So we see that it's an executable, and we need to look at things that would enable us to actually look at the source code behind the executable. So there's a lot of cool things and a lot of cool ways to go about doing this. So one thing that we need to confirm is that if this is a Python executable, this makes things so much easier to just confirm whether this executable is actually uh, Python Python executable or not. We just go to strings, the name of the executable, grep for actually getting whatever the things that we need to, and just type in Python. And yeah, we see a lot of Python stuff that is actually compiled, um, showing up in our strings output. So we confirm this is a Python executable. So to actually disassemble and view the source code, there's a couple of steps, and there's a lot of really cool tools. Let me, there is a tool called PyInstructor. If I go to my browser and type in PyInstructor or something, yeah, so here it is. So it's a PyInstaller extractor is a standalone binary version. So it enables us to extract the contents of a PyInstaller generated executable file, which is exactly what we're looking for. So you just git clone it and run the file on the executable. So I've already installed this in my system. So just pulling up and going on to PyInstructor and the Python file, and then looking at our executable. Okay, I did a quite silly mistake over here. And then it would actually start the process of extracting all the entry points, all the modules of the executable file and convert it to something, a PYC file. Let's look at what a PYC file is. So PYC file is a compiled bytecode file that is generated by the Python interpreter when a script is imported or executed. So it's the intermediate step between a complete source code and a complete executable. So once we've actually, so it has successfully extracted the PyInstaller archive. So so under this directory, we see that the the Python bytecode file is available. So there is another tool to decompile from a PYC file to a Python file, which is our source code tool. Yeah, let's look at GitHub. Okay, there is a lot of tools, and another good tool is using Bilingual. It's a website, so it makes things easy for us. So this Bilingual tool basically converts the Python bytecode file into a source code, a Python source code. We just accept that and browse for our file. Okay, let's do that. Okay, okay, I've already done this, so let's just do that. Import the PYC file into the website and wait for it to decompile. And there you have the fully decompiled Python source code, which is the source code for the malware. It's quite a big file, so we just go ahead and then download it and open it in VS Code, and we just pull the Python file here. Okay, let me download it again. Seems like my antivirus wiped it out. Okay, I think I stored it in a different directory. Okay, I should be having this in under config probably, or here. Nope, we don't see that here. Let me just download it again and store it in the proper directory under forensics and new. Now we should be able to see the Python file, and it's quite a long file. It's about 400 lines of code. Yeah, it's about 400 lines of code. So I'll be uh, quite fast on this to cover all the important parts of the important points of the encryption or the malware. So we see a couple of fernet keys, a variable called fernet keys. This is probably um, the type of ciphers that is instantiated. We also see a key XOR variable that looks like probably a key. We see a AES function that does what an AES does. So AES stands for Advanced Encryption System, which is a really famous and awesome encryption type. So here is XOR, pretty famous one as well. So we also see Fisher encryption. So overall, it takes in three encryption types: AES, XOR, and Fisher, and compiles and encrypts the file. And we also see something interesting here. This T API and T chat ID probably looks like a Python API for a API bot. This is our objective, and it's really a good time to store this. Let me open up Notepad because I'm on Windows. So I'll come back to this in a bit. So we also see a couple of browsers getting installed, getting referenced. We see a lot of common and really widely used browsers. So it seems like it does some sort of bypassing, gets the login paths, get passwords. We also see uh, we also see it does some sort of cookie things and some sort of syscalls. So it's really a well put together sort of malware, and this is not exactly like real life malware, but it's quite gives you a sense of an idea of what a real life malware looks like. So if we scroll down a bit more, we'll see a function called steal, which is another important function that we'll look at. So we see it stores the cookie, stores browser's passwords, and also stores extracts a couple of system information. With some syscalls, it gets the name of the computer, the OS, CPU, GPU, RAM, and a lot of other things. And we see that it's referencing some sort of API in the format of JSON, and then we see that some sort of stealing logs from the system and probably sending it over to the Telegram bot, which is also referenced here. So it uses the send document path to send the document, probably in a zip file. And so after all that it's done, it references this link. Let's go visit that. So it's basically what it does it after all the encryption, it forces the user's wallpaper and changes it to this particular image. So all your files are encrypted. Now you know that now you know the power of the All Father. Okay, he's Odin, I mean the father of Thor or something. So it does that, and you see that it also makes Odin want to say hi to text file in your desktop, and it writes that all your files are encrypted. If you want to recover your files, just send me okay, whatever the image that is. I will give you a program to decrypt. Okay, quite funny, and it shuts the system down. Once you analyze this entire well-crafted, almost could convince most, even my Microsoft antivirus, and probably would convince even the virus total analyzer, and convince that it is a indeed a real ransomware, because it's referencing um a Telegram bot API, and it sends documents in zip format to the Telegram bot. So for now, there are two parts to this challenge. So one is that we've been given a cipher, a set of ciphers that goes through a lot of not a lot of three sets of encryption. One is the AES, the second is the XOR, and third is the Fernet encryption. So I've already written, not written, I've referenced a decryption script. It's somewhere over. Let us look it up. There is the solve.py. So it's in pictures and solve.py. So basically, what this does is that first it references the key and the the ciphers and the parts of the ciphers, and then there's a lot of cryptographic intricacies that not going through, because it's already been a lot of time. It unpads data, it decrypts AES, it XOR decrypts, and overall we do three types of decryption: the AES, XOR, and Fernet. If you haven't heard of these encryptions, these encryption types, it's a really good time to go and look them up. And then it takes in an encrypted file, wukong.png.odin, which is the one that is affected, and it also decrypts the Odin file and basically recovers the Odin ransomware and decrypts it to a normal PNG. So if we run this file, it takes some time, and it gives us uh, the decrypted thing, which is right over here. I've already ran the script, so that's what it does. So Well, going over to pictures and looking at the wukong.png file, we get to see the first part of the flag. So quite important things from this code analysis that we see that it's a telegram bot that's being referenced, and it sends the system information in sort of a zip file and sends it to that particular telegram bot. So our objective is to get more information about the telegram bot. So let's pull up telegram API. So once we have this, scroll back down and look at this particular URL. Let's copy this, go on to our browser, paste this in, and instead of send document, let's just leave it blank for now, and erasing the reference as well. Now copy the API ID, API hash of the bot, and paste it in. Let's try and okay, so it's asking for a description. So a usual Telegram bot, actually, when you want to look at basic information on the bot, we go to specific file URL paths. So to look that up, Telegram bot information path. So let's also do API. Okay, so once you've done some sort of basic reconnaissance. Okay, so it's get me. To access information about a Telegram bot using the API, you would use the path api.telegram.com, your slash bot and your bot token and slash get me. So let's do that. So when we visit this, we see that we see the basic information of the bot. Let's copy this and go on to our notepad. Okay. We see that the name is called Black Meat Wukong. The username is Black Meat Wukong bot. So all this Telegram API is falling into place. So furthermore, to extract more information from this bot, let's go on to Telegram. So I've already done this. So you'll be having already a couple of messages from the bot to me. I'll be explaining that in a bit. Okay, not this. Turn up your Telegram web, yeah. Going on to Telegram web, we see we would be able to see the bot. So waiting for it to load. Okay, there it is. So this is the bot in question, and so this bot satisfies all the this is the black meat Wukong bot, and once you once you've under you've reached this sort of uh, location or your progress in your challenge, once you see any bot, you just start interacting with the bot with the command start. So once you've done that and do some sort of the commands that it supports, um, it gives you it actually sends some information to the bot, and to uh, the objective of doing all this is to get our chat ID of our particular interaction with the bot. So to get our chat ID, we send some sort of information and uh, some sort of communication, initializing communication with the bot in order to get our chat ID. And to check a chat IDs, once you've done further reconnaissance on Telegram APIs and how bot works with Telegram API, you would go to get updates path. So once you've gone there, you'll see a lot of information for a lot of people that have already done communications with the bot. So you just need to look up your name. So that is my name, and and you would probably be looking for your chat ID, which is this. Let me store this. So this is another important piece of information that we've gotten. And now the final thing to do is to basically forward all the information or all the files that have been that the infected system has been sending to the bot. We instead act like a man in the middle sort of attack and basically forward all the messages in to our chat ID. So to do that, there is actually a script written by some genius or something. But you could actually get the essence of what is actually going on in the background. So the script is copied the script in my secondary monitor, and opening terminal, you go on to PowerShell because we are doing a Windows forensics analysis. Um, and you do this sort of, okay, so it goes something like this. So you start off with the basic some sort of brute forcing or fuzzing kind of thing of sending all the messages uh, from the previous 100 interactions or 10 interactions. We'll go with 10. So 1 period 10 and 10, and pipe it to for each object, invoke a web request, invoke, oops, web request, and URI as, and specify the URL that we are looking for, https semicolon forward slash api.telegram.org slash the bot, and the transaction hash, API hash of our API bot, of our Telegram bot. We pasted in there. And also another path in Telegram is, instead of get me and get updates, we go to forward messages. Another cool thing to do that. So another cool path that we've discovered. And we do method, the type of HTTP method that we're doing is post, and the content type, we specify the content type also. The content type is in JSON. Okay, that's what we want. And also specify the body of the request, the post request. And so yeah, under body we, okay, instead of curly braces we go to parentheses and do semiquotes, and under semiquotes we do another a curly braces thing, and then we specify from chat ID that uh, the chat ID of the bot, which we've gotten as minus so and so number. So we paste it in there, chat ID, and also specify the chat ID of our location, of our chat ID. I mean, like forward it to our chat ID, which is, so that is the reason we went through all the procedure to get the chat ID of our application communication with the bot. So here we do the chat ID of our target, so of our chat. So this is the chat ID of our target, I mean of ourselves. And then uh, we actually do something. Okay, so we do also specify the message ID. So in since we actually don't know the exact message ID that we're looking for, we do it something like sort of fuzzing or brute forcing all the message IDs from 1 to 10. So we do it as we do a plus symbol and a dollar sign. So this dollar sign is a special variable in PowerShell that basically references the variable from the pipe. So since it's from 1 to 10, it takes in all the variables from 1 to 10. So we finished off with another plus symbol and yeah, and then we close off the curly braces from the invoke web request URI, and then that basically concludes the script, and then we click enter. Okay, so we probably done some mistake over here. Let me check again. Hmm. Okay, this should probably be good. Let me just change the number of brute forcing that it does so that it doesn't really affect other competitors. Like during the live CTF, you wouldn't want to affect the availability of the bot. So let's do it 10, and then make sure that chat ID and message ID of our things are okay. So yeah, that is our chat ID, and then click on enter. So it fails for the first two times, but it actually does send me the message. It gives me a status code of 200, and it sends all the chat ID from the bot and forwards it to our chat ID. So it's a really cool stuff, all that you get to do in with API in Telegram. It's which is really powerful. So we see that we received a couple of random YouTube videos that we see. If we make it to send more things, okay, we see that we've been getting a lot of things. Okay, so this is our objective. We see a rather curious GitHub link. Let's let's move into there, and we see the source code of the malware. As you can see, we see all the key format and the XOR key with the God bless AS all functions. So as you scroll down, a rather uninteresting way to finish off this challenge is when you scroll down, you see a peculiar looking string. So this should probably mean something. So when you go on to CyberChef again, so clearing all this away and pasting it in, you see that CyberChef automatically instantly recognizes the type of encryption. So it's base 85, and this gives you the second part of the flag. So that's it for the write up, and I guess I wasn't really boring. I mean, maybe I hope that I wasn't really boring. And a couple of issues that we need to fix. There's a first for everything, and yeah. So basically, that's bye bye.